Deep beneath the desert floor, an isolated facility sat behind meters of reinforced concrete. It was built to withstand airstrikes and completely disconnected from the worldwide internet. But in late 2007, a single thumb drive crossed the threshold. The moment it plugged into a workstation, a silent program began executing in the background. It did not steal data. It did not display extortion messages. It searched for a specific target. On screen, every system metric registered completely normal. Down in the hall, thousands of steel centrifuges spun at supersonic velocities. Unbeknownst to the operators, foreign code took direct control of the motor drives. It forced the rotors past their structural tolerances while feeding fake normal data to the monitors. Plant engineers had no idea anything was wrong. Inside the casing, heavy metal components violently shredded themselves. No alarms sounded because the software intercepted the warning signals before they reached the monitors. Operators assumed the failures were caused by bad parts or poor manufacturing. Over 2 years, over 1,000 centrifuges were destroyed in total silence. High-ranking officials began suspecting internal sabotage, yet found no evidence of physical tampering. Thousands of miles away, 2 state intelligence agencies had spent years designing a digital missile. The weapon required 4 separate zero-day exploits, vulnerabilities unknown to software creators. It carried stolen digital certificates from real tech firms, so operating systems would trust it without question. Operatives targeted external contracting companies servicing the target facility. An unsuspecting worker plugged an infected drive into a personal workstation. From there, the worm hopped silently across 5 intermediary networks until reaching the closed facility. The cyber weapon operated with surgical precision, executing only under hyper-specific hardware conditions. In 2010, an IT firm in Belarus was hired to fix rebooting computers in the region. When researchers extracted the payload, they were stunned by its massive size and complexity. Standard viruses use 1 zero-day exploit. Stuxnet carried 4 simultaneously. Security researchers around the globe began breaking down the massive binary payload. Global infection maps showed 58% of affected machines were concentrated at one site. Analysis revealed the code-targeted specific variable frequency drives made by Siemens. It raised centrifuge rotation speeds to 1,410 Hz for 45 minutes before dropping them to 2 Hz. The physical metal expanded and contracted rapidly until the centrifuges shattered from stress. Once exposed, plant security purged thousands of infected systems and confiscated all portable drives. Armed security stepped up patrols, but the physical destruction had already been achieved. Western analysts estimated the cyber attack set back the country's enrichment timeline by 2 years. The worm contained a hard-coded kill date, permanently deactivating itself after June 24, 2012. Stuxnet proved that code alone could tear apart heavy industrial infrastructure without firing a shot. Critical infrastructure facilities worldwide were forced to rewrite their digital defense protocols overnight. Neither government nor wormbearer officially admitted to creating the weapon. It remains the first documented instance of malicious code causing physical destruction in the real world. The era of purely digital warfare had officially begun, and the world's most critical systems would never be safe again.